Hi everybody, today I'm going to show you how to use Minitab to find probabilities for exponential distributions. Exponential distributions model the time between random independent events. Notice that the graph of an exponential distribution decreases as the value of x increases. For these distributions, we have a rate parameter. For our purposes, the rate parameter is going to be called m, but in many places you will also see it referred to as lambda. This parameter is crucial in exponential distributions. It helps us determine how often events occur over time. A higher rate parameter leads to shorter time intervals between events, indicating a more frequent occurrence. In Minitab, we need to enter the scale and threshold before we select the option for the type of probability we want Minitab to calculate. For the scale, you're entering the mean value for your exponential distribution. The threshold parameter in an exponential distribution is used to shift the distribution to the right. If you know that the event you're modeling can occur before a certain time, you can set the threshold to that time. Options will let us select the type of probability we want to calculate, less than, greater than, or between two values. So let's look at some examples. Let's say you need to install a brand new LED light bulb. You go to the store to pick one out. You read the information from the producer and find a light bulb that will last a long time. You select a bulb that says its average lifetime is 1,000 hours. Let's find the probability that the bulb fails in the first 500 hours. In this case, we're finding the probability that x is less than 500. I'm going to go to Minitab to find the probability. I'll start by going to Graph. I'll click on Probability Distribution Plot, View Probability, and select OK. I'm going to change the distribution to exponential. Notice it pops up a scale and a threshold. The scale is our average, which we said was 1,000. I'm not going to change the threshold. I'm going to go to the options. Because I want to find the probability that it failed in less than 500 hours, less than is to the left, and I want to find a specified x value. My specified x value is 500. I'm going to select OK and OK. In my graph, I can see the probability that the light bulb is going to fail in less than 500 hours is 0.3935. Next, let's find the probability that the bulb lasts longer than 1,200 hours. That means this time we're finding the probability that x is greater than 1,200. In Minitab, we'll go back to Graph, Probability Distribution Plot, View Probability, select OK. It stays on exponential, it kept our scale. We're going to go to the options, change our x value to 1,200, and select right tail because we want a value greater than 1,200. We push OK and OK. Now we can see it's shaded to the right of 1,200 to show greater than, and it gave us a probability of 0.3012. Next, let's find the probability that the bulb fails between 800 and 900 hours. Back to Minitab, again we push Graph, Probability Distribution Plot, View Probability. Then in the options, we change to the middle because we have two values. Our smaller value is 800, our larger value is 900. On the graph, we can see this really small area of 0.04276. As always, when you're putting these numbers into your homework or the quiz, make sure you pay attention to how many decimal places you're supposed to put in and whether you're supposed to put in the number as a decimal or as a percent. A company's firewall logs show that on average, there is one unauthorized intrusion attempt every 4 hours. Assume the time between intrusion attempts follows an exponential distribution. Let's find the probability the next intrusion attempt will occur within 2 hours. In this case, our mean is 4, and we want to find the probability that x is less than 2. So we'll select Graph, Probability Distribution, View Probability. We keep it exponential, but we change the scale to 4 because the attacks happen on average every 4 hours. On the options, we're going to select left tail because it's less than, and we change our number to 2. We get a value of 0.3935. This says there's a 39.35% chance that the next intrusion will occur in the next 2 hours. Let's find the probability that the next intrusion attempt occurs after 6 hours. After 6 hours means that we're looking at more than 6. We're going to find the probability that x is greater than 6. So after we go back to graph, probability distribution, view probability, we'll change in our options to go to the right tail for an x value of 6. This produces a probability of 0.2231. Finally, let's find the probability that the next intrusion attempt will occur within the next 5 to 10 hours. So we're finding a probability that x is greater than 5 but less than 10. Graph, probability distribution, view probability. In the options, switch to the middle, put in a low of 5 and a higher value of 10. So we have our x value 1 and our x value 2. We select OK and OK. You can see the 5 and 10 in the graph with a shaded area of 0.2044, which we interpret as a 20.44% chance that the next intrusion attempt will occur in the next 5 to 10 hours from now.